You clicked because you have heard the nickname, the Doomsday Glacier, and you want to know if that fear is real or just a scary headline. Here is what I found. Scientists tracking Thwaites Glacier in West Antarctica reported that this one glacier is already responsible for roughly 4% of all global sea level rise. And the newest measurements suggest it can break down far faster than anyone watching from satellites ever recorded. That figure comes from the International Thwaites Glacier Collaboration, a joint program funded by the United States National Science Foundation and the United Kingdom's Natural Environment Research Council. The detail most coverage skipped is not in the press releases. It is buried in the mud on the seafloor. I want to show you the exact study, the robot that mapped it, and the one sentence a British scientist said that made me stop reading and just stare at the screen. Because what is happening under this ice does not stay in Antarctica. It reaches the coastline where you are sitting right now. Let me start where I started. At 11 at night, with a paper open on my laptop and a cup of coffee going cold. I had read the word doomsday 100 times. What I had never done was ask the obvious question. Why that word? Why this glacier? Out of the thousands of glaciers on Earth. So I stopped reading the summaries and went to the source documents. And the first thing I learned reframed everything. Thwaites is not a small glacier. It is enormous. It covers an area roughly the size of the state of Florida or the whole island of Britain. On its own, it drains a huge basin of ice off the West Antarctic ice sheet and pushes it into the Amundsen Sea. Every single year, it dumps around 50 billion tons of ice and water into the ocean. That is not a forecast. That is a measured, ongoing loss reported by the researchers monitoring it. But the size was not the scary part. The scary part was the word the scientists themselves kept using. They do not describe Thwaites as just a glacier. They describe it as a cork, a plug, a doorstop, because Thwaites sits in front of a much larger body of ice, and it is physically holding that ice back from the sea. As long as Thwaites stands, the ice behind it stays mostly put. And if Thwaites gives way, it opens the door for the rest. Here is the number that goes with that. If Thwaites alone were to melt completely, it holds enough ice to raise global sea level by around 65 centimeters. That is more than 2 feet of ocean from one glacier. But because it acts as that cork, its collapse could destabilize enough of the West Antarctic ice sheet behind it to eventually contribute something on the order of 3 meters, close to 10 feet, of sea level rise over a much longer time. That is the reason for the nickname. It was never about melting fast in a single season. It was about being the keystone. So my first clue was clear. Thwaites matters because of what stands behind it. But that raised a bigger question, the one that actually pulled me down this rabbit hole. If we have been watching this glacier from space for decades, how bad is it really getting and how fast? Because the satellite record and the seafloor record, it turns out, do not tell the same story. And that contradiction is where this investigation really begins. If you have been following this kind of evidence trail and want to go deeper than what any single video can cover, I put together a book that lays out the full framework. Storm Signal, Storm Intelligence, and Storm Alert are 3 volumes that walk through exactly how to read the source documents behind stories like this one, understand what the models are actually saying, and spot the buried details before they become headlines. The link is in the description. If you are the kind of person who just watched this far into a video about seafloor ribs and grounding lines, these books were written for you. Now let me get back to the satellite record, because the story it tells is only half the picture. For years, the number everyone quoted came from satellites. Spacecraft measuring the grounding line of Thwaites watched it retreat. Now let me explain that term simply, because it is the single most important idea in this whole case. The grounding line is the exact spot where the glacier stops resting on solid bedrock and starts floating on the ocean. Think of it as the anchor point. Where the ice is grounded on rock, it is stable and it holds. Where it lifts off and floats, warm seawater can get underneath it and start eating it from below. So the position of that grounding line is everything. When it retreats inland, it means the ocean is winning, reaching farther and farther under the glacier. Between roughly 2011 and 2019, satellites clocked parts of that grounding line retreating at a bit over 1 kilometer per year. That already alarmed people. That was the accepted headline number. Then a team went and actually looked at the ocean floor in front of the glacier, and what they found rewrote the timeline. In 2022, a study came out in the journal Nature Geoscience, led by Alistair Graham, a marine geophysicist at the University of South Florida. His team sent an autonomous robotic submarine called RAN right up to the front of Thwaites into water no ship had ever surveyed at that resolution. That robot mapped the seabed in extraordinary detail. And on the bottom, it found something like a set of ribs, row after row of small ridges carved into the mud. Those ridges are footprints. As the glacier's grounding line pulls back, it leaves a mark in the seafloor with every tidal cycle, almost like a series of tiny terraces. By measuring the spacing between those ribs, the team could reconstruct how fast the glacier had retreated in the past. And the answer stopped me cold. At some point, within roughly the last 2 centuries, Thwaites retreated at a rate of about 2.1 kilometers per year. That is twice as fast as the fastest retreat the satellites recorded between 2011 and 2019. Read that again. The glacier has, in its recent history, moved backward at double the speed we thought was the worst case, based on modern instruments. That is the buried detail mainstream coverage mostly glossed over. The satellite era is short. It only shows us the glacier moving in slow motion compared to what it is physically capable of. The seafloor is the long memory, and the long memory says, this thing can lurch. And then came the sentence. Robert Larter, a marine geophysicist with the British Antarctic Survey and one of the study's authors, described the situation in plain words. He said, Thwaites is holding on today by its fingernails. Fingernails. Not a computer model, not a projection for the year 2100. A scientist who helped map the actual seabed telling us the glacier is barely gripping. So my second clue slotted into place. And it was worse than the first. The problem is not just that Thwaites is retreating. The problem is that its retreat can accelerate in sudden bursts, faster than our satellite record ever caught. And the seabed proves it has done exactly that before. But that still left a hole in the case. A retreating grounding line is one thing. What I needed to understand was the ice you can actually see, the floating shelf out front, and whether it was about to fail. Because that is where the next clue came from. And it came with a countdown. Thwaites has a floating extension called the Thwaites Eastern Ice Shelf. Picture it as a giant floating raft of ice attached to the front of the glacier, spread out over the sea. That raft does important work. It presses against an underwater mountain, a pinning point, and that bracing helps slow down the ice flowing off the land behind it. As long as the shelf holds, it acts like a hand on the brake. Therefore, the health of that shelf became the next thing I had to check. And what I found came from a presentation that got a burst of attention and then strangely faded from the conversation. At the American Geophysical Union meeting in December of 2021, glaciologist Erin Pettit of Oregon State University laid out what she and her colleagues were seeing on the Thwaites Eastern Ice Shelf. The shelf was developing cracks, fractures spreading diagonally across it, weakening it the way cracks weaken a pane of glass. And Pettit used an image that I have not been able to shake since. She said the shelf could shatter like a car windshield. She and her team put a rough timeline on it, warning the shelf could break apart within about 5 years, possibly sooner. Now, 5 years from late 2021 lands us in our present window. And this is where I want to be very careful and stay exactly with what the scientists reported, because this is a case, not a horror movie. The shelf has not vanished, but researchers have documented the fracturing, advancing, the pinning point, losing its grip, and the shelf becoming steadily less able to do its bracing job. The mechanism Pettit described is playing out in the observations. Here is why the windshield image is so precise. When glass is solid, a small crack goes nowhere. But once the glass is under enough stress and the cracks link up, the whole pane fails almost at once, not crack by crack over decades. Pettit's warning was that the eastern ice shelf had reached that kind of brittle state where the failure would not be gradual, it would be a jump. And that connects straight back to the seabed ribs from the last clue. Because if the shelf that is bracing the glacier shatters, you remove the hand from the brake, and the grounding line behind it is free to do exactly what the mud shows it can do. Retreat in a fast lurch, not a slow creep. So now I had 3 clues sitting on the table. Thwaites is the cork holding back a much larger ice sheet. Its grounding line can retreat at double the satellite error rate, proven by the seafloor. And the floating shelf that slows it all down was fracturing toward a windshield-style failure. The picture was getting clearer and darker at the same time, but I know exactly what a lot of you are thinking right now because I thought it too. This is Antarctica. It is the most remote place on the planet. A glacier at the bottom of the world, cracking apart, sounds like somebody else's problem, thousands of miles from any coast you will ever stand on. So let me talk directly to you, the person who figures this cannot reach your town. Because this next part is the part that is actually about you. And it is the part the headlines almost never connect. Sea level rise from a place like Thwaites does not spread out evenly across the globe like water filling a bathtub. That is the intuition most of us have, and it is wrong. And understanding why is genuinely useful. A giant ice sheet has its own gravity. All that mass actually pulls the surrounding ocean toward it, piling seawater up near Antarctica. When the ice sheet loses mass, that gravitational pull weakens, and the water it was holding close sloshes away toward the rest of the planet. The counterintuitive result, which oceanographers have modeled carefully, is that when West Antarctic ice melts, some of the biggest sea level increases show up far away, including along the coastlines of North America. So the ice at the bottom of the world has a direct line to the shoreline of the United States. That is not doom talk. That is the physics of gravity and mass. And it is why researchers studying Thwaites keep emphasizing distant coasts. Now, here is what you can actually do with that, without any hype. First, you can find out your own exposure using real government tools, rather than guessing. In the United States, the National Oceanic and Atmospheric Administration maintains a sea level rise viewer, a free online map where you type in your area and see how different amounts of rise would affect your specific streets on real elevation data. If you live near any coast, spend 10 minutes with it. It turns an abstract global number into your neighborhood. Second, watch the language in the official reports, because the scientists have already started adjusting it. NOAA and its partners now publish sea level rise scenarios that specifically flag the possibility of faster rise if Antarctic ice, and Thwaites in particular, behaves the way the seabed evidence suggests it can. When you read a coastal flooding outlook and it mentions an intermediate high or high scenario, that higher branch exists in part because of this glacier. That is the direct link between a robot mapping mud in the Amundsen Sea and the flood maps for your county. Third, and this is the simplest one, pay attention to what your area calls nuisance flooding or sunny day flooding. That is the minor high tide flooding that happens now on clear days with no storm at all. NOAA tracks it, and the number of those days has been climbing along many United States coasts. It is the early, quiet signal of a rising baseline. You do not need a glacier expert to notice your local roads flooding on more clear days than they used to. That is the story of Thwaites arriving in slow motion, and you can see it yourself. So no, This is not somebody else's problem in a place you will never go. The mechanism reaches your coast, the tools to check your own risk are free and public, and the early signs are already measurable. That is what makes this worth understanding instead of just fearing. Which brings me to the piece I have been holding back. Because everything I have shown you so far, the cork, the seabed ribs, the fracturing shelf, all of it was known and at least somewhat reported. But there is one more finding, the newest one. And it is the piece that made me realize the models we have been trusting might be missing something fundamental. This is the clue at the center of the case. In May of 2024, a study was published in the Proceedings of the National Academy of Sciences, led by Eric Rignot, a glaciologist at the University of California, Irvine, working with NASA's Jet Propulsion Laboratory and colleagues in the United States and abroad. Rignot is not a fringe voice. He is one of the most cited researchers in the entire field of ice sheets, someone whose satellite work basically defined how we measure glacier loss. And his team used something new to look at Thwaites, extremely high-resolution satellite radar from a commercial constellation called ICEYE, which can measure how the surface of the ice rises and falls by tiny amounts, day after day, with the tides. Here is what they saw, and here is why it changes the picture. Remember, the grounding line, the anchor point where ice lifts off the bedrock? We used to picture it as basically a fixed line, with the ocean on one side and solid, sealed ice on the other. Rignot's team found that is not what is happening. They detected seawater pushing far inland underneath the glacier, well past the grounding line, and then draining back out in rhythm with the tides. The ocean is not politely waiting at the edge. It is being pumped in and out beneath the ice like a bellows, twice a day, every day. They measured this tidal seawater intruding for kilometers under the glacier, into places we assumed were sealed off. And warm seawater under ice does exactly what you would expect. It melts it. The team described this process driving what they called vigorous melting in a zone we had basically not accounted for. Because here is the quiet, devastating part of the finding. The circumpolar deep water reaching under Thwaites is only a couple of degrees Celsius above freezing. It sounds harmless, but there is so much of it pumped so persistently under such a huge area that even a couple of degrees is enough to hollow the glacier out from beneath, far inland from where we were watching. And now the sentence that, for me, closed the whole case. Rignot and his co-authors stated plainly that this tidal seawater intrusion is not represented in the ice sheet models currently used to project sea level rise. Read that slowly. The mechanism they just documented, warm ocean water pumping kilometers under the glacier and melting it from within, is largely missing from the very models that produce the sea level numbers governments plan around. Which means those projections, the ones on the flood maps, are quite possibly on the low side. Rignot has said as much, that these findings suggest current projections of sea level rise may be underestimates. That is the finding at the center of everything. Not that Thwaites is melting. We knew that. The revelation is where and how it is melting. Not just from the visible edge, but from deep underneath, in a place our instruments barely reached and our models never included, driven by an ocean that gets a fresh push twice a day with every tide. Let me connect the whole trail now, because this is the moment it all clicked for me. The seabed ribs from the 2022 study told us Thwaites can retreat at over 2 kilometers per year, double the satellite rate. The fracturing eastern ice shelf from Pettit's 2021 warning told us the brake that slows it is failing. And now, Rignot's 2024 radar tells us why the retreat can outrun our expectations. Because the ocean is already inside, melting the glacier from beneath the grounding zone, in a way the projections do not capture. 3 separate teams, 3 separate methods, a robot on the seabed, a warning at a science conference, and a satellite watching the tides, all pointing at the same conclusion. Thwaites is more vulnerable than the standard numbers suggest, and the standard numbers know it. This is why that fingernails quote stayed with me. Robert Larder did not say it for drama. He said it because when you actually read the source documents, one after another, the picture they paint is of a glacier that is barely holding, being worked on from every direction at once by processes we are only now learning to measure. And that is the part I most want you to walk away with. The alarm around Thwaites is not coming from activists or headlines. It is coming from the measurements themselves, from the National Science Foundation and the Natural Environment Research Council, from peer-reviewed journals, from a Nature Geoscience paper and a PNAS paper and a NASA-affiliated team, each one adding a piece that the last one could not see. The story mainstream coverage tells you is that a far-off glacier is melting. The story the source documents tell is that we may have been measuring the wrong part of it all along. So here is where that leaves you and me. Most people will keep hearing the word doomsday, roll their eyes, and scroll on, because it sounds like hype. You now know it is not a slogan. It is a description of a keystone glacier that the seabed says can lurch, that the shelf says is losing its break, and that the newest radar says is being melted from the inside by an ocean we did not know had gotten in. You see, the thing most people are still missing, and that is exactly who this channel is for. You are the kind of person who would rather read what the scientists actually reported than accept the watered-down summary someone wrote to fit a headline. You want the paper trail, the names, the dates, the real numbers. So let me ask you something specific, and I genuinely want your answer. Of everything in this case, which clue hit you hardest? The robot finding retreat at 2.1 kilometers per year in the mud, the ice shelf that could shatter like a windshield, or the seawater being pumped kilometers under the glacier with the tides? Tell me in the comments. And tell me where you are watching from, because I want to know how close you are to a coast and whether that NOAA viewer showed you anything that surprised you. If you want the next one, here is what I am already digging into. There is a second glacier right next to Thwaites Pine Island Glacier, and its own ice shelf has been losing large pieces in ways that the recent data suggests may be linked to the very same warm water current feeding Thwaites from below. I am pulling the source documents on it now. Subscribe and stay with this. Not to support a channel, but because you want the real evidence dug up and laid out plainly, before it becomes the headline everyone else is suddenly repeating. I found the buried detail on Thwaites. I want to find the next one with you watching. I'm John, and if you've watched this far, you're my kind of viewer. This video gave you the overview, but inside the Weather Watch, I continue the full seafloor evidence trail, picking up right where we stopped. And in there, you can ask me your own questions. And I answer you myself, not some bot. You belong with us. Just point your phone's camera at the code on screen, and you can cancel anytime.